exactly?
Sir, but I have one request, sir. At last, you have draw four diagrams. The four diagrams are very important for troubleshooting. That only I need.
1 minute.
Yes, sir.
Let me check the recording is start on. You need not to worry about the troubleshooting. You will learn the troubleshooting while you will work.
Yes, sir.
Only I am sharing my experience so that you can crack the interview.
Yes, sir.
Okay?
Yes, sir. Yeah.
So guys, for today, we will discuss about something more about the static routing. So do you know about the permanent entry? Anyone?
No, sir.
Suppose that here a router R1, R2, R3, and we have configured the static routing on via exit interface or next hop IP on R1, R2, and R3. Okay? So let's suppose this link goes down. This link goes down. So we can directly save the permanent entry of static routing in this R1 routing table. So if this link goes down, then router 1, what will router 1 do? It will automatically remove this entry from its routing table. Okay? Are you getting my point?
When the link goes down, the link, then it will remove the path. Router. Yes, no.
Once this link goes down, R1 will remove the entry from its routing table about the 11th network. But
Yes, sir.
if we manually enter a permanent entry in the R1's routing table, then either is this link goes down or it is up or this link is continuously flapping. There is no impact on R1's routing table. It will always show the 11th network route in its routing table. Is it clear for everyone? Abdul,
Yeah, uh,
is it clear? Permanent entry?
yeah. It's like how we were like creating the entries by creating like a static routing. It's like similar, like it's like
Yeah, it's similar. Only a last keyword we need to add in the static routing, that is permanent. I will write the command. I will show you. Subhajit, Ravi Shankar, is it clear for everyone?
Yes, sir.
Okay. So the command will be here R1 config IP route 11.0.0.0 255.255.255 dot. What will be the subnet mask in the last octet? Subnet mask value
252.
and a keyword you need to add here, that is permanent. And before that, this keyword you need to add the exit interface or next hop IP. Next hop IP here 10.0.0.2. Guys, is it clear?
Yes, sir.
Yes, sir.
Subhajit, Abdul,
If you have like a multiple router,
Yeah, clear.
15 router, do we have to like make permanent to all of the entries, or how does that work?
yeah, you can make it. You can make it. But in the dynamic routing, especially in BGP, there is a thing that called as route dampening. Let's suppose here three routers R1, R2, R3, R4. Here we have connected these routers with each other. And continuously this link is flapping. It is going down and coming up, going down, coming in. So if continuously this route link is going down and always once the link goes down, this router will remove the entry, and after that once this link come up, this router is adding the entry of this network in this. So CPU utilization will be high or not?
Answer.
Abdul,
Yeah.
CPU utilization on these router will be high because this link is continuously flapping. It may be possible in an ISP network, especially in the case of ISP. You will get a number of links continuously flap due to the lot of issues. Okay, so what we need to do, either if we are using the static routing, we can use this permanent keyword to permanently add. Okay, or if we are using the BGP, then we can use the route dampening. It's a very advanced topic, CCIE level topic, route dampening. Guys, clear? Permanent entry is clear. We should move for the next.
Yeah.
Yeah, sure.
I think I should write this command again, or it will be fine for you guys. Only silly mistake. What I did here, I didn't give the exit interface or next hop IP before the permanent. You need to give it, and you can check it on the packet tracer. This command. Should I show you this command on the packet tracer, or you guys will do the practical?
We'll do the practical, sir. Continue.
Okay. Next topic is load balancing. in static routing. There is no by default load balancing, especially in Cisco routers. Okay, for static routing, you will need to configure. First of all, you need to enable Ceph. Without enabling Ceph, load balancing will not work. Okay, Ceph is another table. It's a kind of table like routing table. It's a table. Another table. It's Ceph. If you want to more information about Ceph, it's not a CCNA label, but you will have to read MPLS for the Ceph. Then you only understand after understanding the tags. First of all, you will need to enable the Ceph by enable Ceph command. Okay. After that, the second thing, once you enable Ceph on a router, particular router, then you will go on a particular router's interface. And you will have to write a command IP load sharing per packet. Guys, try to understand this topic. Here, if you have multiple paths, to reach from a source to destination, and we want to send only 10,000, suppose that 3,000 packet from this router to R1 to R3. Okay, so if we use only one link, then the bandwidth consumption on a particular link will be high and speed will be slow to deliver the packet. So speed will be slow. But at a time, if we distribute these 3,000 packet across these three lines by 1,000 packet from this line, 1,000 packet from this one, 1,000 packet will be from this one. Bandwidth consumption will be low or high? Abdul, if you are distributing,
Yep. Different link, then it should be low.
it should be low. Then the delivery
Yeah,
rate of packets will be high. Speed will be high. So for achieving the speed, we will have to enable IP load sharing per packet. This command we will have to use. In the live scenario, only for a small enterprise network. Uh, have you ever seen Taco Bell, Dunkin' Donuts restaurant,
mm-hmm.
McDonald's, Pizza Hut? These kind of restaurants, they have a network diagram, because for USA I have worked for this, especially for the Comcast client.
Mm-hmm.
Suppose that this is a firewall and this is a router and these are the two switch. Here are the PCs. And here it is another router which is connected to these switch also, and here it is in another firewall for the backup purpose. So, and it is also connected with each. For the backup purpose, we connect this router to this firewall and this firewall to this router. Guys, is it? Are you getting my point? Should I draw another diagram?
Understand, sir.
Subhajit and Abdul.
No, sir, it's okay.
Subhajit, Abdul.
Yeah, the only in this topology that we're
One
showing the
minute,
two
one minute.
files.
Let me write down. These are two routers. These are two firewalls. They are connected with each other. Now for the backup purpose, suppose that this firewall goes down and this is up. So the traffic is coming from this router will goes down. So we can connect it from here also. And now if there are two switch, we can connect these switch. These one. This is network design. And these are the PCs. So here you are seeing if you only use one router at a time, then we will not able to achieve the load balancing. Here, if you want to forward this this router's packet from only this firewall, then will be the bandwidth consumption will be high. Are you getting my point? If we will use only this link, so what will we do? We will enable the routing. If we are using the static routing here, we will start the load sharing per packet. So suppose that this uh, router is getting request from 4 PC, then it will forward the 2 requests from this firewall and 2 requests from this firewall. Is it clear for everyone? It's a real-time scenario which I am discussing. It's a real-time network design. Especially for the Dunkin' Donuts, they use these kind of things. And Taco Bell.
So is it like we are working this topology? Is it like describing about like using
Just,
like
just I'm giving an example for the IP load sharing.
Just as a backup, we are using if one link
we are
goes
using
down, then
as a backup, but at the same time we are using both link. Backup mean doesn't mean when this link will goes down then only we will use. No, backup means simultaneously we will use both. And if one link goes down, so it's a prevention from the packet drop. Then all the traffic should be forwarded from this link only.
okay.
Okay, there are some configuration. Once you will reach to the HSRP and VRRP topic, then you will able to understand. Guys, it is clear? IP load sharing per packet command.
Yes, sir.
So first of all, you need to enable the Ceph, and after that you need to configure this command, IP load sharing per packet. Clear, guys?
Yeah.
Anyone has any doubt? Abdul, do you have any doubt?
No, no, I'm good.
Okay, good to go? Okay, so the next topic, our let me discuss something about the dynamic routing. Then after we will move for the packet flow in the same subnet.
Sir,
Yes.
the like why to use the exit next hop address instead of using exit interface, even if exit interface is present, like this concept.
Yeah, we will discuss in the packet flow, recursive lookup problem and
Yes, sir.
proxy R. Don't worry about that.
Yes, sir.
If here I will only give you the definitions only. I will not able to explain it.
Okay.
Okay. So today we will cover the packet flow in the same subnet, and tomorrow we will cover the packet flow in different subnet. I want to cover the packet flow so that you guys can understand how exactly a router works and switch works. So there are two types of dynamic routing. First is IGP and second one is EGP. So IGP means Interior Gateway Protocol, and AREGP means Exterior Gateway Protocol. Is it clear, guys? So what do you mean by the Interior Gateway Protocol? Interior Gateway Protocols, like, they work in the same autonomous system, and the protocol like EIGRP, OSPF, ISIS, RIP. These are the interior gateway protocols. Okay. Exterior gateway protocol, BGP is an BGP, MPBGP is the exterior gateway protocol. So interior gateway protocol work, it works only in same autonomous system. And it can connect to different autonomous system. In short, I am writing AS. Okay. You need not to worry about the autonomous system. Once I will start to discuss the EIGRP, I will discuss what is an autonomous system. It cannot handle lakhs of prefixes in its routing table. It can handle lakhs of prefixes, more than 1 lakh, 2 lakh prefixes in it routing table. So guys, this one is a very important question, especially for the L2 level. They will ask you, okay?
Yes, sir.
So it works only within an ISP. It uses to connect two different ISPs. Is it clear, guys? So what
Yes,
is an
sir.
interior gateway protocol? Interior gateway protocol work only in a same autonomous system. And exterior gateway protocol used to connect two different autonomous systems with each other. Interior gateway protocol cannot handle lakhs of prefixes in its routing table, but exterior gateway protocol can handle more than 10 lakhs of prefixes in its routing table. Okay?
Prefixes, are you referring to the routers, like number of routers, or what?
No,
The
no.
prefixes.
Prefixes doesn't mean that the router. Prefixes means, let's suppose, uh, this is 10th network, 10.0.0.0/30. This is 11th. This is 12th. This is 13th. This is 14th. This is 15. This is 16. This is 17. This is 18. So these networks will called in the routing table of R1 all the network. Once you will configure this topology, these network ID will call in the routing table as prefixes.
Hmm.
Did you get?
Yeah.
What are the
Yeah.
exactly
Uh,
prefixes? Network ID of
one,
networks in a routing table of a router called as prefixes. Simple.
sir, your voice is breaking. Could you please repeat one more time the definition?
Okay. So the network IDs of networks, different networks in the routing table of a router called as prefixes. So suppose that we are either in a data center or an ISP network, there will be a huge number of routers, even more than in thousands. Router will be in the thousands, and you will also configure a backup path. So prefixes will be in lakhs of prefixes, lakhs of networks you will have to configure. Okay? So there is a limitation of the IGP protocols. So they cannot handle, I think, more than 50,000 prefix in its routing table. Abdul, is it clear for you?
Yeah, all of this is working in one geographical location, I think, right? In one
Yeah,
one.
they can work in a same geographical location. It may be possible they are working in different geographical location. You know,
But
undersea,
when it
these
comes to
cables
like
are going from.
different ISP,
Yeah, maybe like if you are in USA and AT&T, Spectrum, Verizon, Comcast are different ISPs. But from if you are using suppose that Verizon and someone is sitting in Comcast, someone is using Comcast. You both are communicating with each other. It means Verizon is transferring its prefixes to Comcast side, and Comcast side is also transferring the prefixes to Verizon.
so they are like both of the ISPs, like they're sharing the
Sharing,
whatever.
and this is with the help of only EGP protocol.
BGP, yeah. Okay.
BGP, and for the some
Auto gateway.
cases VRF and MPLS we use MPBGP, but mostly BGP only. BGP only. Is it clear?
Yeah.
So dynamic routing. How many kind of dynamic routing? There are two kinds of dynamic routing protocols. One is IGP and second is
BGP.
EGP. So there are four type of IGP protocols. First one is DVRP. Second one is ADVRP. Third one is LSRP. And for EGP, there is a type of protocol TVRP.
These protocols are different than the dynamic routing. The
No, no.
EIGP
IGP
and
is a kind of dynamic routing, and EGP is a kind of dynamic routing. And we are using EIGRP, RIP, OSPF. They have their own properties. So on the behalf of their own properties, these we define this distance vector routing protocol. DVRP means distance vector routing protocol. I am explaining what exactly means of distance vector routing protocol. Don't worry about that. ADVRP. Advanced distance. LSRP. Link state routing protocol. So RIP an example of DVRP. EIGRP is an example of ADVRP, and OSPF is an example of link state routing protocol. Subhajit, what is the full form of PVRP?
PVRP, it's a periodic
Path vector
path vector routing protocol.
routing protocol. Lakshman, take the screenshot if you want. And BG,
Sir, I have noted it, sir.
you have noted down?
Yes, sir.
Because I am going to open a new tab.
Yes, sir.
Okay. In distance vector routing protocol, DVRP, metric. Yesterday we discussed about the metric. Metric will be calculated on the basis of distance. So let's suppose R1, R2, R3. What is the exact meaning of metric? Subhaji,
Cost to reach
Abdul, what is the
the
exact meaning
destination
of
network.
metric? Yesterday we discussed.
It is
think it's
cost to reach given
calculation
network.
of the best path in the routing.
No. Metric means what is the cost to reach from a source to destination. Suppose if you want to reach from R1 to R4, what is the
That's is gonna
cost?
calculate the path, right? That's what it means, right?
Yeah. So here in DVRP, cost will be calculated on the distance. So suppose that it is this packet is going from two routers. So distance will be 2. Cost will be 2. Sorry. Cost will be 2. And suppose cost will be 3. Because this link, it is using this link and this link and this link. Suppose we have another path. R1 to R3. And we are sending the packet from this path. R1 to R3 and R3 to R2. R4. What will be the cost? 2 only?
Yeah, 2.
Abdul,
Yeah, 2. Yeah.
if you are directly connecting it, what will be the cost?
1. Huh?
1.
3. Directly connected
Zero,
to 1.
0,
1.
maybe.
For the directly connected, it will always be 0.
Okay.
Is it clear, guys? How to calculate the cost? And in DVRP example, what is the example of DVRP? RIP, RIP an example of DVRP. Okay, so guys, metric will be calculated on the basis of distance. So distance DVRP always share its entire routing suppose R2 is a neighbor of R1. Whatever R1 has in its routing table, it will share entire information with R2. Guys, do you guys know how to check the routing table of a router? What is the command in Cisco?
Show IP route.
Show IP. Is this point is clear or not?
Yes, sir.
It is clear.
Yes, sir. But all routing protocols will share their entire routing table.
No, all routing protocol no.
Okay, sir.
So the next topic is ADVRP. So guys, it has the property of DVRP and LSRP. Okay, so in LSRP, in DVRP, in DVRP, they will only share the routing table information. But in LSRP, they will also share the entire link information. Suppose that R2 is sharing that I have a 12 network in my routing table and 13 network in my routing table to R1. So it will not only share that 12th and 13 network are in my routing table, it will also share that 12 network is connected with R3 and 13 network is not directly connected with me. It is connected R3 and in between of R3 and R4. So it means it is giving the information of each and every link. Guys, did you get link state routing protocol?
Yes, sir.
Means
Basically,
it
this combination of both, I think, right?
No, in link state, I am talking about right now link state routing protocol, so that I can explain the ADVRP. It is giving the information about the each and every link. Suppose Lakshman is giving uh, some gift to Abdul, okay, and Abdul is showing that gift to Subhajit. So only Abdul is not showing that if only Abdul is showing that gift to Subhajit. This is called as the distance vector routing protocol. But if Abdul is showing that gift to Subhajit and telling to Abhijit, I got this gift from Lakshman. So if he is saying I got this gift from Lakshman, this is link state routing protocol. And if he is saying that showing the gift and also saying that I got this gift from Lakshman, it means DVRP and LSRP both. Did you get the point? Should I give another example?
Sir, it gives the link information like R1 is directly connected to R2, but R1 is not directly connected to R3, like that. Am I
No,
correct?
no. It will share the information. This is the 12th network in my routing table, and I got this network from R3, and this network from R3 it is directly connected.
Okay, sir.
Okay, and if R2 will share this information, its routing table. Suppose that it is an 11th network to R1. Then R2 will not only give the 11, 12, 13 network, then it also will tell to the R1 that 12 is directly connected with me and 13 is not directly connected with me. It is directly connected with, I am getting this 13th network with the help of the 12th network, and this 13th network is directly connected with R3. Did you guys get the point? Abdul and Subhajit, Ravi
Yeah,
Shankar,
basically, it's giving you the information about like the one which is not directly connected out.
which yes, one which is not directly connected. Exactly. And telling that it is directly connected with this one network.
Yeah, okay.
Okay. Did you got it? The properties of ADVRP and LSRP.
Yeah,
I will show you once I will start the, by the next week I will start the EIGRP, and in the next week I will complete the EIGRP and OSPF. Subhajit, Ravi Shankar.
yes, sir.
Yes, sir.
So next one is path vector routing protocol. Which protocol is called as the path vector routing protocol? ISIS or OSPF?
Uh,
Or BGP or EIGRP? Just 10 minutes before.
BGP.
I told you guys.
BGP,
BGP.
BGP.
Exactly. So path, what means of the path vector routing protocol? Once I will do the practical of EIGRP and OSPF, I will show you how this ADVRP and LSRP work exactly. Okay? Don't worry about that. but just here it's a theory part. Path vector routing protocol. So suppose R1 R5 is sharing its routing table to R1. Let's suppose. So it will share the entire information of the path. So this is the path, these properties, these attributes are working on this path. So there are 12 attributes of BGP. Okay. So R5 will share all the information to R1 about the entire path. If a second path is available also, then it will share the information about the second path also. So which attributes are used on this path? This information will be shared. Here there is no attribute will be shared. Only it will share the connection, not about the attributes in LSRP, ADVRP and DVRP. But here in the path vector routing protocol, entire information of the path. What does it mean? It means the properties which are used on that path, it will share also in the its routing table. Is it clear, guys?
Sorry, sir, not understand why.
Suppose R5 is sharing, this is an autonomous system 100 and this is at an autonomous system 200. And this link is uh, this link is
Sir, meeting is about to end.
okay. 1 minute. Let me send the again. Okay, Lakshman, guys, my screen is visible.
Yes, sir. Received.
Okay, suppose that bandwidth here 2 GB and here 5 GB, and suppose latency is 10 second, here 2 second. So this R5 will not only share the routing table, this R4 is connected with R1, will not only share the routing table with R1, it will also share the all information about that. It has 2 GB bandwidth, latency is 2 second, here autonomous system is 100, here autonomous system is 200. This is the link information. It has the prefix of 12.0.0, means entire path information R4 will share to the R1. Is it clear for you?
Yes, sir. Additional to like directly and not directly connected network, it also share additional information like autonomous system,
Yeah, entire
latency.
information of the path.
Yes,
That
sir.
here
Now understand.
this one bandwidth, and it will also share you that the next hop IP for my R4 is here for 13th network is, suppose this interface is 2. So it will also tell to the R1 that my next hop IP for 13th network is 13.0.0.2. For 12th network, my next hop IP is 12.0.0.1 for this interface. And it will also tell to the R4 will also give the information in the R1 that here link is up and I am able to reach to these two next hop IPs. Is it clear?
Yes, sir.
So entire information of the path R4 will share to the R1, and similarly R1 will share to the R2 will share to the R1, and R1 will share to the R2. The important thing in the path vector routing protocol, we manually have to configure the neighbor. But in ADVRP, DVRP, and LSRP, We need not to manually configure the neighbor. Okay, I will show you how ADVRP and DVRP LSRP directly send the hello packet, and on the behalf of the hello packet exchange, they decide this one router is my neighbor. Okay. Who is asking to join? So Abdul, is it clear for you? Subhajit and Lakshman, Ravi Shankar,
Yes, sir, clear.
Yes, sir.
PVRP is clear. Path vector routing protocol.
Yes, sir.
So now the next topic is, it's a very important topic, especially for the L2 engineers. And if you will apply for the any tag, Cisco, Sienna, Alcatel tag or Juniper tag, they will ask you, surely they will ask you this question. Either in same subnet or in different subnet. In a company in Hyderabad, DNS Global, in an interview, the interviewer asked me, explain the packet flow of DHCP, each and every step from sending the ARP and getting the IP from DHCP server. Okay, with it least time. So it is the most important topic.
Sir, will you also teach the DHCP packet flow?
No, it's
Okay.
part of the CCNP, not CCNA. So guys, let's suppose here, what meaning of the same subnet, Abdul?
Meaning of what? Subnet.
Same subnet.
I mean, if let's say if we have like a network slash 24 or 26, we will be using like a same subnet from that particular network.
Same subnet means simply means they are in same
Same net.
network.
Yeah, same network. Yeah.
Suppose 10.0.0.0/30. So what will be the network here? Network ID will be 10.0.0.0. Here first valid IP will be 10.0.0.1. Second 10.0.0.2. So these four IP addresses are the part of the same subnet. This one is network ID and this one is broadcast, and these two are valid hosts. Okay. Abdul and Lakshman, is it clear?
Yeah.
Yes, sir.
So let's suppose this PC's IP address is 10.0.0.2 and this PC's IP address, one /30 network I am using it. 10.0.0.2 /30 network means I am using this network. Okay. So, and suppose this PC's MAC address is 0A and this PC's MAC address is 0B. Guys, everyone knows about the MAC addresses.
Yes, sir.
Okay, and here this PC want to send a packet. Suppose hello, Lakshman and Abdul are sitting in the same organization and they want to talk each other, and Lakshman is saying hello to Abdul. Okay, so this hello packet will go from this PC to switch, and from switch to this PC. After that, Abdul will reply hello, then this PC will send a message to this switch, and switch will forward it to this PC. So entire process is not so similar. It's a very complicated process. So first of all, you need to understand when Lakshman will generate hello message, okay, then an ICMP echo request will generate. Okay, from PC number 1, ICMP echo request will generate, and this ICMP echo request will have echo request type. Anyone who knows, echo request type always be 8,
0.
code will be 0. Okay, what is the protocol number of ICMP? Anyone knows? ICMP protocol number is 1. Is it clear? So this PC1 is generating the request. So what is the source IP?
10.0.0.1.
One minute. Source IP will be 10.0.0.1. So source IP MAC
A0A whatever.
0. Yeah. So did PC2 know about the destination IP? Yes, destination IP PC2 no. Destination IP, it is knowing that I am sending this packet to 10.0.0.2. Did the PC1 knows about the MAC address of PC2?
Don't know.
Abdul, will
Only
be
forwards
Lakshman able to
package,
know about the
right?
will the Lakshman know about your PC's MAC address?
No.
No. So here, if Lakshman didn't know about the MAC address of the destination, what will be the destination MAC address? Target MAC will be
0B.
0. Is it clear for everyone? Guys,
0B only destination MAC address.
no. Do you know about the MAC address of Abdul computers?
No, no, do not
No.
know.
So if
Yeah.
you don't know, then it will type only the 0. Okay.
Yes, sir. Okay.
Let now So ICMP packet will generate from PC1, but it doesn't know it will reach. Here it doesn't know about the MAC address. So first of all, there is a requirement that target MAC address will PC1 will get the target MAC address. So for getting the target MAC address, PC1 will generate an ARP request. PC1 will generate. What PC1 will generate?
ARP request.
What is an ARP? ARP is address resolution protocol. So address resolution protocol, it helps to get the target MAC address. Okay, this protocol help you to get the target MAC address. Is it clear for everyone? Right.
Yeah, sure.
Please give me reply. It's a very important topic. An ISCMP packet will generate here, but target MAC we don't
Yeah.
know. So this packet will be discard. It will wait for 2 seconds, and after 2 seconds this packet will be destroyed. But it doesn't know about the target MAC address. So first of all, PC1 need to get the target MAC address. So that is why it is generating another request. This is the ICMP request, echo request, and this one for the target MAC address. To get the target MAC address, PC1 will generate an ARP request. Is it clear? So when the PC1 will generate the ARP request, what will be the source IP address?
10.0.0.1.
Destination IP address?
10.0.0.2.
Source MAC?
0A.
But in ARP request, it doesn't know the destination MAC.
Address.
So in ARP request, what the PC1 will do, it put FF in all field. That I don't know about this destination MAC address. Okay, so ARP request will generate by the PC1, and now this ARP request will reach to switch from PC1 to switch. Okay, guys,
Yes, sir.
it is clear for everyone. Abdul, any doubt ask here. Very important topic. Subhajit,
Yes, sir. Clear.
Clear? Ravi Shankar,
Yes, sir. Yeah.
clear? Abdul is not replying.
No, I'm just like a little confused with the first concept. Second one, I got it. The first one is like
Here,
yeah,
you
the
want
first
to
one.
communicate. Here you are confused, I think. Here you want to. Here you are confused.
Yeah, the first
So
one. Yeah. That's very good.
you want to communicate with PC2. The communication will be by which protocol? ICMP protocol. So
Yeah.
ICMP protocol source IP will be 10.0.0.1. Source MAC address will be 0A. Destination IP will be 10.0.0.2.
Right.
First of all, PC1 will check this IP destination IP addresses MAC address in its table, in its MAC table. MAC table of which? MAC table of PC1. It will check.
Right.
It will didn't get. It will not get the destination MAC address. Okay. Then what will PC1 do? PC1 will write the destination MAC address at 0 as 0, 0, 0. So without knowing the destination MAC address, ICMP protocol cannot work. Okay. So what is the packet life of a ICMP protocol? Only 2 seconds.
Okay.
Only 2 seconds. So it will take the time to make an header in which source IP is 10.0.0.1 source MAC address. It's a process of PC to define these all things. So once the ICMP will not able to send the packet without knowing the target map, then PC1, what will PC1 do? It will generate an ARP request to get the target MAC address. Is it clear, Abdul?
Yeah. Can we do the practical when we get a chance on this one?
Surely I will show you. Surely I will show you, and I want to uh, increase the duration of this class today. It may be by 15 to 20 minutes. So that is why here I want a break, and I want to continue after the break, the class. Guys,
Yes.
are you ready to just give me 20 minutes so that I can complete this topic today?
Yes, sir.
Yeah,
Okay?
yes, sir.
Please save this page.
Yeah, I will save the page, and here I am pausing the recording also, and I will start.
Yeah.
Okay? Don't worry about that.